The prototype pattern is a creational design pattern in software development. It is used when the type of objects to create is determined by a prototypical instance, which is cloned to produce new objects. This pattern is used to avoid subclasses of an object creator in the client application, like the abstract factory pattern does. Avoid the inherent cost of creating a new object in the standard way when it is prohibitively expensive for a given application. To implement the pattern, declare an abstract base class that specifies a pure virtual clone method. Any class that needs a polymorphic constructor capability derives itself from the abstract base class, and implements the clone operation. The client, instead of writing code that invokes the new operator on a hard-coded class name, calls the clone method on the prototype, calls a factory method with a parameter designating the particular concrete derived class desired, or invokes the clone method through some mechanism provided by another design pattern. The mitotic division of a cell resulting in two identical cells is an example of a prototype that plays an active role in copying itself and thus, demonstrates the prototype pattern. When a cell splits, two cells of identical genotype result. In other words, the cell clones itself. Structure. Rules of thumb. Sometimes creational patterns overlap. There are cases when either prototype or abstract factory would be appropriate. At other times they complement each other. Abstract factory might store a set of prototypes from which to clone and return product objects. Abstract factory, builder, and prototype can use singleton in their implementations. Abstract factory classes are often implemented with factory methods, but they can be implemented using prototype. Often, designs start out using factory method and evolve toward abstract factory, prototype, or builder as the designer discovers where more flexibility is needed. Prototype doesn't require subclassing, but it does require an initialize operation. Factory method requires subclassing, but doesn't require initialization. Designs that make heavy use of the composite and decorator patterns often can benefit from prototype as well. The rule of thumb could be that you would need to clone an object when you want to create another object at runtime that is a true copy of the object you were cloning. True copy means all the attributes of the newly created object should be the same as the object you were cloning. If you could have instantiated the class by using new instead, you would get an object with all attributes as their initial values. For example, if you are designing a system for performing bank account transactions, then you would want to make a copy of the object that holds your account information, perform transactions on it, and then replace the original object with the modified one. In such cases, you would want to use clone instead of new. Pseudocode. Let's write an occurrence browser class for a text. This class lists the occurrences of a word in a text. Such an object is expensive to create as the locations of the occurrences need an expensive process to find. So, to duplicate such an object, we use the prototype pattern. Class word occurrences is, field occurrences is, the list of the index of each occurrence of the word in the text. Constructor word occurrences, text, word, is, input, the text in which the occurrences have to be found, input, the word that should appear in the text, empty the occurrences list, for each text index in text, is matching, equals true, for each word index in Word, if the current word character does not match the current text character then, is matching, equals false, if is matching is true then, add the current text index into the occurrences list. Method getOneOccurrenceIndex, n, is, input, a number to point on the nth occurrence. Output, the index of the nth occurrence. Return the nth item of the occurrences field if any. Method clone is, output, a word occurrences object containing the same data. Call clone on the superclass. On the returned object, set the occurrences field with the value of the local occurrences field. Return the cloned object. Text, equals the prototype pattern is a creational design pattern in software development first described in Design Patterns, the book. Word, equals pattern D, search engine, equals new word occurrences, text, word, another search engine, equals search engine clone. The search algorithm is not optimized. It is a basic algorithm to illustrate the pattern implementation. See example, this pattern creates the kind of object using its prototype. In other words, while creating the object of prototype object, the class actually creates a clone of it and returns it as prototype. You can see here, we have used memberwise clone method to clone the prototype when required. Java example, this pattern creates the kind of object using its prototype. In other words, while creating the object of prototype object, the class actually creates a clone of it and returns it as prototype. You can see here, we have used clone method to clone the prototype when required. References. Sources: Gamma, Eric. Helm, Richard. Johnson, Ralph. Lasides, John. Design Patterns, Elements of Reusable Object-Oriented Software. Addison Wesley. ISBN 0-201-63361-2. See also, Function Prototypes,